Okay, so we just looked at a story about just numbers. There was no fluff to this story, was there? So, let's go back, pick it apart, start at the beginning, and read to each punctuation mark, shall we? So it reads, one number is 9 less than a second number. Okay, so what information do they give me? Yeah, they're talking about two numbers, aren't they? They say one number, and then they say a second number. Well, instead of one number, can we say the first number? Would that be okay with you? All right, so here's the deal. This is, to me, the most important part about solving stories, word problems, is writing down the information in a nice, neat manner. So we have the first number, and then we also have the second number, and it reads that the first number is 9 less than the second number, right? So the first number is. When you translate is into math, what's it translate to? Yeah, equal. So first number is 9 less than. What's the less than mean? Yeah, you're going to subtract. Now the question is, does the 9 come before or after the minus sign? Because remember, it's 9 less than something else. Good, so it goes after. So 9 less than something else. And the something else in this case is the second number. So I'm going to use S. And you're like, what's S stand for? Well, that's a good question. What's S stand for? Because knowing most of you, you probably put an X instead. And I would ask you the same question. What's X stand for? Yeah, it stands for the second number. Correct? Okay. And then it reads, 3 times the first number is 3 more than 6 times the second. All right, so thankfully there's no fluff to this story. So let's start that again. It says 3 times the first. So 3 times the first number. What's it say after that? Is. So what are we going to write? Equals. 3 more than. So more than means to add. That's true. And the question is, where does that 3 go? Before or after? So 3 more than something else, right? So that means you're adding 3 to something else, aren't you? And what are we adding 3 to? 6 times the second number, right? 6 times the second number. Good? So we kind of did half English, half math here. Agreed? And that's okay. We're allowed to do that because that'll help us out. And then it says find the numbers. Okay, so I'm noticing this equal to sign is kind of giving me an equation, isn't it? So it said 3 times the first number. Well, what's the first number? What's representing the first number? S minus 9. So 3 times S minus 9 equals 6 times the second number. Well, what's representing the second number? S plus 3. Good? And now we have a nice little equation to go solve, don't we? Okay, so follow along. I know you guys know how to do this. The left side needs to be distributed. And then we need to put our variables all on the same side, don't we? Okay, so I'm going to bring my 3s over to the right. Why? I want the s's to be positive, which means I'm going to subtract the 3s from both sides. And then I'm going to bring this plus 3 to the other side because I brought all the s's to the right, which means the guys that don't have s's go to the left. And then divide by 3. So in this case, I have s equaling a -10. Good? Okay. Now, the story didn't say anything about positive or negative numbers, so I really don't care what the sign is. If it came out negative, fine. But here's what we need to understand. What does S represent? S represents the second number. So I'm telling myself basically the second number is a -10, isn't it? So the first number, Yeah, you're going to have to do negative 10 minus the 9, which in this case is negative 19. So, your first number, negative 19. Your second number, negative 10. Good? Hang in there. Got another story for us. Okay, so it looks like the next problem is like a geometry problem because they're talking about a triangle, aren't they? All right, so I don't know about you, but I'm going to draw a triangle. And they told me that the perimeter of this triangle is 88 centimeters, right? Good. What else did it say? It said two sides are equally long. All right, well, this side and this side then will be the same length. And it said the third side is 10 centimeters longer than the others. So I guess this side, if it's 10 meters longer than, I'm going to add 10, and I'm going to add 10 to what? I'm going to add 10 to that S, right? Okay, and they want to know the lengths of these sides. Well, help me out. Perimeter is adding all the sides together. Good. So, what are you going to add? Yeah, you're going to add S plus S plus S plus 10. And that should equal 88. Good? Well, this was a nice problem, wasn't it? All right, so let's collect our like terms. Sorry, my brain's running ahead of what I'm writing, so I have to slow it down. There we go. And then, good, I got S equals 26. Did you? So, one side is 26 centimeters, isn't it? The second side is also 26 centimeters, isn't it? The third side, yep, add 10 to it, is 36 centimeters. Good? Yeah, this was a nice problem. Hang in there. I'll be Okay, so let's look at the next story. The next story talked about an aircraft carrier, correct? And so now we have some fluff to the story. And they said, or they called the aircraft carriers A and B, didn't they? Okay, so let's go back, start at the beginning, read up until each punctuation mark, and see what information we can glean out of the story. So, there are two aircraft carriers, A and B, and there's a comma, so I'm stopping. So, yeah, I don't know about you, but I'm going to write aircraft carrier A and aircraft carrier B. All right. Carrier A is longer in length than carrier B. All right, so I know this one is longer. And so so anyway, got it? Okay. Pick it up from that punctuation mark. It said the total length of these two carriers is 2,178 feet. So the aircraft carrier A, they're talking about its length, aren't they? And the same with B, because they've now given me a total length, haven't they? And what they say the total length was? Yeah, the total length is 2,178, and it's in feet. Cool? Okay. And after that comma, it says, while the difference in their lengths is only 10 feet. Okay, let's see. Difference in length. So hold on a second. Let me come back over here because they're wanting us to find the length of each carrier. So let me come back over here a second. The total length is 2,178, right? Do I know the length of aircraft carrier A? Did they give me anything about its actual length? No. So here's the deal. I am going to call it A. And what about, did they tell me anything about the length of aircraft carrier B? No. So I'm going to call it B. Got it? Okay. The reason I wanted to put the variables in was because that last line said the difference of their lengths is 10 feet, right? Okay. So difference in lengths is, that's right, equals 10. So when they talk about the difference, what operation is that? Good, that's subtraction. So I know when I subtract, it's supposed to equal 10, isn't it? Now, mind you, I have to subtract their lengths, don't I? Okay, so be careful. Which aircraft carrier is longer? A. So A needs to go first because that's a positive 10. So I'm going to do A minus B equals 10. Cool? Because the longer one minus the shorter one is equal to 10, right? All right. Now here's the deal. I have two variables. So in order for us to solve this story, I'm going to need two equations because I have two variables. So I have one equation, A minus B equals 10. Any idea where a second equation would be? Yeah, right here, because the total length means you're going to do what operation? Add. So I'm going to do A plus B equals 2,178. Cool? Okay, so two equations and two unknowns. You have three methods of solving. You can either graph these two equations, you can use the substitution method, or you can use the elimination method. The choice is yours. And I know some of you already have an idea what you're not going to use. You're probably not going to use graphing. I'm not going to use graphing either. I don't think it's the best technique, especially if answers come up to be fractions. And if I don't have grid paper, it's even worse. So I'm going to choose either substitution or elimination. Personally, I'm going to go with elimination. And some of you may be going, why? Because I chose substitution. Here's why I'm going for elimination. Because the elimination method says that whatever variable we're eliminating, the coefficients, the numbers in front of that variable are the same number and opposite signs. Well, I'm noticing the b's. In front of b is a -1 and on this one is a +1, which means it's totally set up for the elimination method. So it's perfect. I'm just going to add. So I'll get 2a, the b's drop, equals 2,188. Agreed? And then all we have to do is divide, and we get 1,094, don't we? Okay. So A is 1,094. I still need to find B, don't I? So I can use one of those equations, and it doesn't matter which equation I use. Let's just use the first one. Why? Because it's a smaller number, that's all. So I have 1,094 minus B equals 10. Solving for B, I'm going to subtract the 1,094 from both sides, which gives me a -1,084, and then divide or multiply by a -1, and I get B is 1,084. Are we good? By the way, we said the difference in their lengths was 10, and A is longer than B, and there's a difference of 10 here, right? So we have aircraft carrier A is 1,094, what's my units? Feet, right? And aircraft carrier B is 1,084 feet. And if I add these together, I better get 2,178 feet. Cool, does this make sense? Hang in there, got another one for Okay, so we just looked at a story where we have students traveling abroad into two countries. We have the most popular host country and the second most popular host country as we read, correct? Okay, so just like we've done, start at the beginning, move on to each punctuation mark, and let's see what it tells us. In a particular year, well, there's a comma, so I'm stopping. Does it tell me anything? Nope, it's fluff. It makes the story sound good. Moving on. A total of 57,032 students studied in two of the most popular host countries when traveling abroad. Any information? Yeah, they gave me a total. And they also said something else. Yeah, they gave me a total of students traveling, right, to two of the most popular host countries. So, here's the deal. And we know because we read this story already, so we know one of them is the most popular host country. I'm going to abbreviate that. And then we have the second most popular host country, right? And these are the number of students that are going to each one. Always a good idea to write this down so you know what you're actually talking about here. Yeah, you're talking about these countries, but you're talking about the number of students going to these countries, right? So in that line, not only did they tell me there was two popular countries, they also said there was a total number of students. And what was our total number of students? Yes, 57,032. Good? Okay. Got all the information out of that first part? Moving on. Pick it up. If 8,484 more students studied in the most popular host country than in the second most popular host country, comma, I'm pausing there, okay? So, we have 8,484 more students studying in the most popular country than in the second most popular country. So, let me ask you something then. Which country is supposed to have more students studying? Yeah, clearly the first one, most popular, right? And it has how many more students studying? 8,484 more students are studying here than in the second one. So if you think about it, I need to know the population of which country right now. And then when I add the 8,484, I'll get the other country. Yeah, I need to know how many students are actually studying in the second most popular host country. Because when I know how many are studying in the second most popular, then I'm going to take the second most popular and add the 8,484 students that it said were studying in them. It was that many more students studying in the most popular than in the second most popular. That than, when I've got something set up like this, that than almost tells me I need to know this one first. And when I know this one, I can add to it to get the second one, or to get the most popular. Cool? Okay. And then they say, found how many students are studying in each country. All right. So gratefully I only have one variable here, right? Which means I only need to set up how many equations? Just one. So total. Total means you're going to do what? Yeah, you're going to add. So let's talk about that. You're going to add, and it's going to equal 57,032. So the question is, what are you adding? So you're adding the students in the most popular host country, and you're adding to it the students in the second most popular host country, aren't you? Well, how many students are studying in the most popular host country? we called it S plus 8,484. And here's the plus sign. We're adding to it the students in the second most popular host country. Well, how many students are in the second most popular? S. And that gives me my total. So the S got written twice here. So what? If that's the way it works out, that's the way it works out. Y'all with me? That's why sometimes it's a good idea to write this part in English so you can make certain that you're writing everything down correctly. Students in the most popular added to the students in the second most popular. Here was in the most popular, here's in the second most popular. Cool? Okay, and so now we get to collect like terms and do our normal solving technique, right? Okay, so now we have to move the 8,484 over, right? Okay, so for the interest of time, I'm going to get my calculator. I know you guys have your calculator. So when I do the subtraction, I end up with 2s equals 48,548. Do you agree with me? Cool. And then, good, divide by 2. So s equals, right? Awesome. Okay, so question. What does S represent? Yeah, S represents the number of students in the second most popular host country. So, second most popular host country, and of course I'm abbreviating, we have 274 students. Now, what about in the most popular host country? How do I figure out how many students are in the most popular host country? Yeah, I'm going to have to take this 24,000 and add the 8,484 to it, aren't I? Okay, so let's see if I did my addition correctly. I know you guys are checking on your calculators, and that's cool. And looks like I got that right. So 32,758 students. Does this make sense? Hang in there. No surprise. Okay, so the next story we read about a woman who is buying frames for a picture, right? Okay, so like we've been doing, you start at the beginning, read up until each punctuation mark, and see what kind of information they are giving us. Cool? And remember, I should say half the battle, and to me the most important part of these stories, and it's not really a battle, but the most important part of these stories is actually writing the information down in a neat, concise fashion that you're able to understand what you've written and then figure out what to do with it from there. So, let's start reading. A woman bought some large frames for $11 each and some small frames for $6 each at a closeout sale. Okay, so what information they give us? Good, we know we're dealing with large frames and small frames, right? And they told us the cost of these frames, right? And the cost is in dollars. It's a good idea to put the dollar symbol up there so you know you're not talking about Russian rubles or something like that. So the cost of the large frames was $11 and the cost of the smaller frames was $6. Correct? Okay. Any other information in that first part? Nope. So let's pick it up from that punctuation mark to the next one. If she bought 18 frames for $138. Okay, any information? Yeah, I'm seeing the dollars, $138. And this is also dollars, isn't it? So what do you think the $138 is representing? One word, 5 letters, starts with a T. The. Good. That's our total. That's our total cost. Our total cost is $138, isn't it? Good. And they also told us in what we read, just in that last part, that she bought 19 frames. Or pardon me, 18 frames, right? Huh. Well, this is cost. And 18 sounds like a total also, doesn't it? But it's not the total cost, it's the total amount of frames, isn't it? Well, looks like I need to make myself a new column, and I'm going to call it the amount of frames. And all I know right now is that the total is 18 of them. Good? Okay. Anything else in that part? So pick it up from that comma. Find how many frames of each type she bought. So I hear a question. Are we at the end? Yep. Did they give me any more information? Nope. So they want to know how many of each frame she bought. Well, did they tell you how many large frames? No. So I'm going to call it L for large. Did they tell us how many small frames? Nope. What do you think I'm going to call it? Yep. S for small. Some of you use X's and Y's. That's fine. I don't like to use X's and Y's when I'm talking a story because X stands for xylophone to me and a Y stands for yo-yo. And we ain't talking about xylophones and yo-yos in here. We're talking about large and small frames. Cool? Okay, so here's the question. How many variables do we have? 2. How many equations are you going to need? 2. Now, for some of you who aren't sure how to set these up, here is a key for you. The totals are what my 2 equations end up equaling. So here's the thing. For instance, the amount of frames, the total is 18, right? So if the total is 18, total means I'm going to do what operation? I am going to add. So what am I going to add to get the total of 18? The number of large frames and the number of small frames. So I'm going to do L plus S equals the 18. So I use the 18. I'm done with that total. Make sense? Okay, but I have a second total, and the second total is 138, so I know my second equation must equal 138. Now here's the deal. Does 11 plus 6 equal 138? Yeah, no, not even. Okay, but let me sidetrack you a little bit, okay? You go to a grocery store, and you're going to buy grapes. Okay, and they are $3 a pound. You buy 2 pounds. You're also going to buy some apples, and they are $5 a pound. And you're going to buy 3 pounds. What's your total cost? What are you going to do? Yeah, for the grapes, you're like, well, that's $6. How'd you get it? The cost times the amount, right? That's 6. And for the apples, that's 15. The cost times the amount. And then you would add the 2 together, the 15 and the 6, right? Well, that's the same over here with the frames. I'm going to take the cost and multiply by the amount. So 11L plus the cost times the amount, 6S. How I figure this out with frames is exactly how I would figure this out with going to buy fruit at a store. Cool? Okay, loving it. So do we have our 2 equations? Yes, we do. And now we have our choices. We can use the graphing method, which I know you're not going to use, because if I'm not going to use it, I know you're not going to use it. And we have substitution method, or we have elimination method. The choice is yours because they don't tell you which one to use. So, what do you guys want to use? Substitution or elimination? Okay, some of you, okay, so I got half of you saying each. So, I think I'm going to go with elimination. And I think I'm going to eliminate the S's. So I'm going to take this entire first equation and multiply by, multiply by -6. Why? Because I want the number in front of S to be the exact same as this one, and the sign has to be opposite, which is why I'm multiplying by -6. So my first equation now looks like negative 6L minus 6S equals, what do you get? Negative 108. Good? All right. So then we have 11L plus 6S equals 138. We add our two equations. Good. 5L. The S's drop equals a positive 30. Well, that was nice. So it looks like L equals 6. Make sense? Okay. Just found L, but you still have to find S. So I am going to use the equation, the first one. Why? Because it's the easier of the two to use. And I'm going to plug in the 6 for the L. And this is going to help me find the S. Good? Okay, so what did L stand for? The number of large frames. So it looks like she bought 6 large frames and 12 small frames. Good? Okay, hang in there. I'll be right back with another one. All right, so let's look at the next problem. The next problem was talking about butterfat milk, right? All right, so when you read that problem, it's one long sentence, isn't it? There's no breaks in it whatsoever, is there? Okay, so let's look at this again. It reads, find how many quarts of 6% butterfat milk and 3% butterfat milk should be mixed to yield 45 quarts of 4% butterfat milk. Okay, so we have how many butterfat milks? We have 3 different ones, right? And what are they doing between 2 of them? They're mixing them together, aren't they? Okay, so hang in there, all right? We have 3 butterfat milks, so hang in there. We have got, and I'm just going to call it this way because they really didn't give them different names. So we have butterfat milk number 1, and then we have butterfat milk number 2, and they're mixing those, aren't they? And when they mix them, they're getting a mixture of butterfat, right? Okay, so this would be the butterfat mixture. Does that make sense? Okay, back to the beginning. Find how many quarts of 6% butterfat milk. So, my first butterfat milk, here's the deal. Not all of the milk is butterfat. Okay? Because you're like, what the heck does that mean? I have milk, and they've added something to it to now make it butterfat milk. Are you with me? So they added a percentage of butterfat. So in this case, they added 6% to it. So now it has, so 6% of this milk is butterfat. That's why it's butterfat milk. Not all of it, just because they added some to it. And they want to know how many quarts, don't they? Okay, so number of quarts. Do we know how many quarts? Nope. So I am going to call it Q for quarts. Cool? All right. And then after that, we have 3% butterfat milk. Okay, so butterfat milk number 2, the percentage of butterfat in it is 3. And I still don't know how many quarts here, do I? Well, okay, so here's the deal. I can't use Q again for quarts, can I? So let's back it up a second. I'm going to call this butterfat milk number 1. I'm going to call it the first butterfat milk and the second butterfat butterfat milk because I got, two of them, and I need to know the number of quarts in each one. Okay? And I mix these together, and it gives me, they actually told me the quarts here, that gives me 45 quarts, doesn't it? And now the content is 4%, isn't it? Okay. So, help me out a second. When you mix things together, what operation is that? Yeah, that's addition. So I know I'm going to be adding these two butterfat milks, and it's going to equal the mixture. Does that make sense? All right. Now, the mixture, I want you to kind of think about it this way. The mixture, if you think about it as the total, will help us out a little bit. I have two variables, right? And I need how many equations? Two equations. So, one equation is a little more obvious than the other one, and it has to do with the quarts. I know that I have a 45 quarts altogether, which means one of my equations is going to be F plus S equals a total of 45 quarts. With me? The second equation is not so obvious. It is and it isn't. Part of it may not be. So here's the deal. The second equation is kind of like the problem we did with the picture frames. And then I talked about the grapes and the apples right in there. And then the problem right after it. Kind of the same type of problem, except it's not talking about frames or grapes and apples. We are not talking about butterfat, and we're talking about a percentage and an amount. So, I am going to take the amount, and instead of multiplying it by a cost, I'm going to take the amount and multiply it by this percentage, so I know exactly how much of the container is actually butterfat. It's not 100%, it's only 6. But I need to find out how many quarts there are so I know how many quarts are literally butterfat. So, I'm going to take the 6% and multiply by the amount. Instead of cost times amount, it's the percentage times the amount. And I'm going to add to it the second one, the percentage times the amount. Are you with me? And it's supposed to equal the total number of, or the total amount of butterfat. Right? Well, they didn't give me a total number here. They gave me a percentage, and that's not necessarily the total number of quarts of butterfat. I'm going to have to do the same thing on the other side of the equal to sign that I did over here. I'm going to have to take the percentage and multiply it by the total quarts, because that will give me the actual number of quarts that are butterfat. Cool? The difference here versus that frames problem, the frames problem literally gave me the total cost of the frames. This isn't a total percentage of that's butterfat. This gives me the percentage of the 45. With me? Okay, well, pause it, rewind, play again. All right? Okay. By the way, some of you are going, why didn't you write these numbers as percentages? I could have, and then I could have multiplied this equation by 100 to have gotten rid of them all. So I'm saving myself a step of work. All right? All right, so here's the deal. I'm going to simplify this second one. So the second equation is 6F plus 3S equals 4 times 45. What'd you get? 180. Good. So I have these two equations. And now it's my choice how to solve. You can use substitution or you can use elimination. I think I'll go with substitution this time. Because some of you are like, do a substitution one. So I'm going to solve for F. So I'm going to do 45 minus S, okay? And then I'm going to plug it into this equation over here. So we have 6 times 45 minus S plus 3S equals 180. Good? Okay, so 6 times 45. Yeah, 270 minus 6S plus 3S equals 180. Collect my like terms, right? So I'm going to get a negative 3S equals 180 minus the 270. Good. Negative 90. So S is 30. Good. And if S is 30, how do I find F? Well, right here. F is equal to 45 minus the S, so F equals 15. So, check it out. That means for the butterfat milk number 1, I have 15 quarts. For butterfat number 2, butterfat milk number 2, I have 30 quarts. Okay. Sorry, I'm debating on showing you something. Well, it might not be a bad idea to show it to you, so you may understand it a little bit better. So according to butterfat milk number 1, 6% of the 15 quarts is actually butterfat milk. So if you take the 15 and you literally multiply it by 6%, which is 0.06, you would get 0.9, wouldn't you? Okay. So this represents 0.9 quarts. Based upon 15 quarts, and 6% of it is butterfat milk, that's 0.9 quarts. It's almost 1 quart, not quite. Butterfat milk number 2, we have 30 quarts now, right? And 3%, so I'd have to multiply by 0.03. Well, in this case, it's also representing 0.9 quarts. With me? The total was 45 quarts, and that was 4%, so I literally have to multiply by the 0.04. So that 4% represents 1.8 quarts. So in these 45 quarts of milk, 1.8 quarts is actually butterfat. And it works out, because 0.9 plus 0.9 gives me the 1.8. Almost 1 quart of the milk is butterfat. Almost 1 quart of this milk is also butterfat. And the mixture, almost 2 quarts of the mixture is actually butterfat. Does that make sense? Does it clear it up just a little bit? Cool. Hang in there. Got another story for us.